Okay, so we're going to be using this rule here, this uniqueness of b to the x. And we've got the same stipulations as we have. B has to be greater than 0. It can't equal 1. And what we're going to be doing for these equations is we're going to be finding a common base. Because if I can get the base to be the same on both sides of my equation, then their exponents have to be the same. It's going to be the only way that that can be true. So what I'm going to be looking at these problems for is a common base. They might start with, like, our first problem starts with a common base. But these are numbers that should be familiar, that you say, okay, that looks it could be 2 to some power, or 3 to some power. They're things that we've seen before. I'm not going to give you way out there numbers. But what we're going to do is we're going to find a common base for our problem. And then if we have to, we're going to rewrite numbers using that base. So for example, I might need to rewrite 9 as 3 squared. Or I might need to rewrite 32 as 2 to the 5th. That's what I mean by rewriting it as with its common base. And once we have the same base on both sides, we can just cross it off and solve the exponents. So this particular process, when you know to use this, if you were doing a test, all the problems are mixed up and it just says solve. There's a lot of problems that say solve. This process works if you're trying to solve an equation where there's a variable in the exponent. That's how you know to use this. There's a variable in the exponent. So we're going to find a common base. Once the bases match, all we have to do is solve the exponents equal to each other. So in my first problem, in problem A, we want to solve the exponential equation for x. I have 2 to the third equals 2 to the x. This is kind of the base example. So the common base here, the common base for 2 and 2 is 2. And they have the same base. Both of their bases are 2. Once the bases are the same, that means that the exponents have to be equal. So we can probably look. If I want, let's think about it, 2 to the third equals 2 to what power? That's what this question is asking. What does that second exponent have to be? It has to be 3 again. And what we're going to do in some of the more complicated problems is once you have the bases the same, you cross off the bases, and then you're just left with the exponents. X is equal to 3. So that's the idea. The basic idea is that once these big numbers match, the exponents have to be equal. It's the only way that's going to be true. So for B, the two numbers I have in my problem are 5 and 625. What I want to do is find a common base for 5 and 625. So what do we think a common base would be? 5. And what I mean by a common base is, well, 5 has already got a base of 5. But is there a way I can rewrite 625 as 5 to some power? Well, 5 to the x is equal to 5 to what power replaces 625? 4. So right now I'm just replacing 625 with 5 to the 4th power. Because I already had the same base, so I could just cross them off. So what we're doing here is we're getting set up so this looks like number 1. No. So now you've got to cross off the 5s. So we got the common base. So both sides are 5 to some power. Once that's the same, you cross off the 5s, and we're left with x equals 4. That's the answer. X equals 4. Does that make sense? And think about it. Think about is it's true. These are really easy to check. What's 5 to the 4th power? 6.5. So that's true. Now sometimes you have x's on both sides, so you might need to look at both values, but whatever you come up with should get you the same value on either side of the equal sign. Now C, we actually solved a lot like C, just kind of intuitively on Monday. But let's do this by getting our common base. So my two sides, now this only works if you have one term on either side. You see all of these are just something equals something. That's how these problems are all set up. So I need a common base. I'm looking one side is 3 to the x, so I need a common base for 3, and I need a common base for 1/9. So what number do you think works for both 3 and 1/9 for my base? 3. So if I look at the left side of the equation, it's already got a base of 3. It's 3 to the x power. What I want to do now is rewrite this 1/9 as 3 to some power. -2. Why do I have a negative? I do that 1 over bit. So this is like we did last time, like we did back in 10.2. When you have the fraction 1 over, your exponent here is negative, and then you just look at 3 to what power is 9. So I'm going to rewrite that right side as 3 to the -2nd power. And then once I have the same base, I cross them off and I see what's left. I get x equals -2. Now D isn't quite as straightforward. In every other example, one of the sides already had my common base. So I just had to worry about one side. But 4 and 8, they have a common base, but it is neither 4 nor 8. So I need to think of some base that's going to work for both 4 and 8. 2. So this time I'm going to have to rewrite both sides with my common base. Well, 4 to what power gives me 8? Yeah, they look like they should be. But you have to break them both down. Because 4 to the first is 4, 4 squared, you're all the way up to 16. So how am I going to replace the 4? 2 squared. Now, you got to be careful because I'm not just writing 2 squared because the 4 already had an exponent. So you've got to make sure if it already has an exponent that you bring it down and they are multiplied. If you already have an exponent and it's a binomial, put it in parentheses and then bring it down. And then how could I rewrite the 8? No, it's not a square root, it's just the number 8. 2 to the 3rd. You're thinking of the square root of 8. The number 8 is the same as 2 to the 3rd power. So is everyone okay with so far how I've replaced the two sides of the equation with their common base? And then once the bases are the same, cross them off because the exponents must be equal based on our uniqueness of b to the x. But this time I didn't end up with x. This time I ended up with another equation that I have to solve. So I have 2x equals 3. It's not a lot of work to solve it for x. Divide both sides by 2. So you don't always straight away know what x is once you cross off your bases. Once you cross off the base, put the left exponent, your equal sign, and then the right exponent. And if there's something left to solve, you need to solve that equation. So to solve this one, we divided both sides by 2. Now the check on this is really easy as long as you don't forget your parentheses. So if you wanted to check this in your calculator, you would do 4 raised to the power, put parentheses around your exponent, and you want to see, do you get 8 back? If you don't put those parentheses, you will not get 8. But you want to take 4, raise it to the powers, parentheses, because we have 2 parts to that exponent, 4 to the 3/2 power, or for this one, you can do 4 to the 1.5 and see if you get back 8. And you should get 8. And the other side is already 8, so we know it checks. Questions? All right, for E, I have 9 to the x minus 1 equals 27 to the x. When you have a binomial exponent, just like when you have binomials in other places, for safety's sake, use parentheses. And now I need to come up with my common base. I need a common base for both 9 and 27. So if you say 9, 9 to what power gives me 27? 9 times 3. But 9 to the third power is 9 times 9 times 9, not 27. So you got to be careful because it does. You see that there are multiple of one another, but we're talking in terms of raised to a power. So common base for 9 and 27. 3, yeah, absolutely. So neither of my sides have a 3 for a base right now, so I'm going to have to, again, rewrite both sides. So how can I replace 9 with a base of 3? Okay.
3 to the 2x minus 3?
Well, oops, sorry, not 2, you said. So let's start with the fact that 9 is getting replaced with a 3 squared. When I bring down the exponent, bring it down in parentheses.
Don't distribute.
You do distribute, but you said 2x minus 3 would be 2x minus 2. Okay, yes. I'm going to distribute on the next step. But whenever you have the binomial, make sure you use parentheses so you're multiplying the whole thing together. And that's equal to, how could I rewrite this 27? 3 to the third. And don't forget, it already had an exponent. Got to bring it down. So any questions on setting up our like bases? And now that they have the same base, I don't need it. The bases are the same, which means the exponents, 2 times x minus 1, has to equal the other exponent, 3x. And since this first problem had a binomial exponent, we're going to need to distribute that 2 to solve. So I have 2x minus 2 equals 3x. What type of equation is this? Linear. So it doesn't have an x squared. None of these will have an x squared. Just throwing that out there. I'm going to bring the 2x over to the right side so I can get this all done in one step. So I have negative 2 is equal to x. Yeah.
But the answer is 3, right?
No, the answer is this part right here. The 3 is just where we have to start. And then once you get both of them to have the 3 for a base, whatever you solve here is your final answer. And then finally for f, I have 5 to the 2 minus x equals 1 over 125. So I'm trying to find a common base that'll let me solve this problem, a common base for 5 and 1 over 125. 5. We don't have to worry about the fact that the right side's a fraction. What we're really looking at is the number, the denominator here. The fraction, we can take care of the fact that it's a fraction really easily. So we're really looking at the 5 and the 125 for its common base, which is 5. And that's a jumping off point for us to get both sides to have a base of 5. Well, the left side already has a base of 5. So I wouldn't even worry about putting parentheses around its exponent because I'm not going to be doing anything else to that side. That side's staying the same. It's still 5 to the 2 minus x. That's not changing. Which side doesn't have that base of 5 is the right side, the 1 over 125. So it's got to be 5 to some power. Now, how do I know, or how do I get a fraction? What needs to be true about that exponent to get it to a fraction? Negative. So it's going to be negative, and then 5 to what power gives me the 125? 3. So to get the fraction 1 over 125, I would use a negative 3. And now that both sides have the same base, drop it off and solve what's left. So what's left is the 2 minus x equals negative 3. And when I solve that, that's how I'm going to get my answer. So to solve for x, I'm going to subtract 2. So I have negative x equals negative 5 and divide both sides by negative 1. By chance. By chance, that one happened to be the same as the common base. But the answer that you'd put would be x equals 5. So how do we know we're going to use the common base method of solving these problems? When I look at one of these problems, it's mixed up on my final, it's mixed up on my Unit 4 test. How do I know I need a common base? Exponent has the variable. When the exponent has the variable, so here, the exponent, 2 minus x, the exponent has the variable. Here, both exponents have variables. That's how you know to use this process. Questions?